a second type of motion diagram or motion graph. And this one deals with a graph that shows velocity versus time instead of position versus time. Okay, so in a position versus time graph, everything on the y-axis was measuring the position of an object. In this case, it's being measured in centimeters. So it said after 0.1 second, they are 20 centimeters away. After 0.2 seconds, they're 40 centimeters away. After 0.3, here's where they are. After 0.4, that's where they are. But it's measuring their position. And so if you look at this graph, we see a straight line that's sloped in the positive direction. So this graph right here would indicate to us that we have constant positive velocity. Would we agree with that? Constant positive velocity. There's no curve, so it's not speeding up or slowing down, and it's moving in the positive direction. So we've got constant positive velocity. And so would I be able to calculate the velocity from that graph right there? Yes, by calculating what? If I want to find... That's right, it is a position versus time graph, but if I want to calculate velocity, what do I need to calculate on that line? The slope. I need to calculate the slope of the line, because remember that the slope of the line shows us velocity. So I would be able to calculate. I not only can describe that it's constant positive velocity, but I would be able to calculate that as well. Now we're going to go take a look at a velocity versus time graph that shows the same motion. This down here is a velocity versus time graph that is showing us the exact same motion. Constant positive velocity. But why is it a horizontal line? Because velocity is being measured on the y-axis and I have constant velocity, that means my velocity is unchanging, right? My velocity is not changing. So on a velocity versus time graph, if you see a horizontal line like this, it does not mean that we're standing still. It means we are on cruise control, right? We've got a constant speed happening. It doesn't mean we're stopped. It means we are moving at a constant velocity. The only time on a velocity versus time graph we would be standing still is if we were on the x-axis. So if I was on the x-axis like that, that would mean that I'm standing still because my velocity would be 0. Right? Does that kind of make sense? So these graphs show us they have two different ways to represent the same motion. One of them deals with the position change and the other deals with the velocity change. And so we need to be really analytical about which type of graph are we looking at, number one, and then how can we analyze that motion, okay? So let's move into this a little bit more. If I'm taking a look at this velocity versus time graph, I want to walk through what's happening in the motion here. Okay, so from A to B, what are we doing? What's happening in my motion from A to B? First of all, I want you to tell me, is it moving in the positive direction or the negative direction? Positive. Okay, now I want to expand on that a little bit. If I kept my graph going, -5 meters per second, -10 meters per second, -15 meters per second, -20, would those all be valid velocities? Can I have negative velocities? Yes, I can. It's going backwards, exactly. So my whole graph is above the x-axis, which means for the entire motion, I am moving forward. That needs to be the difference. In a velocity versus time graph, above the axis means I'm always moving forward. Below the x-axis means I'm moving backward, right? Because if my velocity is negative, that would mean I'm moving backward. And that's a difference, a big difference for us between position versus time and velocity versus time. Excuse me. From A to B, what am I doing? Not quite. From A to B, what am I doing? I'm going forward. I know that because I'm above the x-axis. So from A to B, I am speeding up in the positive direction. Okay, right? We know positive direction because we are above the x-axis. From B to C, what am I doing? I'm constant speed. So I'm at constant velocity. From C to D, what am I doing? Speeding up in the positive direction. Yep. From D to E, what am I doing? Say it again. Constant velocity. So from D to E is constant velocity. From E to F, here's where it gets a little trickier. From E to F, what happens? I am slowing down, but I'm still moving in what direction? The positive direction. Very good. So I'm slowing down in the positive direction. From F to G, I've got constant velocity. And then from G to H, I'm speeding back up. So I'm speeding up, positive direction. Okay, how do we feel about the breakdown of what's happening in that motion? Does that part make sense to us? So think about this. As we approach the x-axis, that's when we're slowing down. And that could mean that I'm coming up at the x-axis or that I'm coming down. Either way, it means that I'm slowing down. Okay? In a velocity versus time graph, now the slope, when we calculate the slope, it tells us something called acceleration. Now tell me, what do you know about the word acceleration? What does that bring to mind? It brings to mind speeding up. That's true. But acceleration is any change in velocity. Any change in velocity is considered acceleration. And now we kind of misuse that term, right? It's not that we misuse it necessarily, but we give it too narrow of a definition. We think that accelerating only means speeding up, when in all reality, acceleration is to have any change in velocity. So speeding up or slowing down are both considered types of acceleration. But in our everyday vocabulary, we use accelerate to think speed up. And that's partially true, okay? So when we calculate the slope of this, we are really calculating the change in velocity, the acceleration, okay? I'm going to give you one more little nugget here with acceleration. The unit for acceleration is meters per second over seconds, which is the same as meters per second squared, okay? Because if my velocity here is measured in meters per second divided by seconds, this is what it gives me, meters per second squared. Okay. Okay, so that's what tells me the acceleration is if I were to calculate this slope. Do you need something? Oh, I'm sorry, okay. But is there a way for me to determine the displacement of my object? Can I tell how far has it traveled from a velocity versus time graph? And the answer is yes. And it's kind of a little shortcut, trick to how to do that. But the way you do it is to find the area under the graph. And I'm going to make a little more of a distinction here. The area under the graph to the x-axis. Okay, so let me reframe what that means. If I wanted to find out how far I've traveled from 0 to 4 seconds. Okay, let's walk through here. I sped up in the positive direction, then I set my cruise control, then I slowed down. But I was always moving in the forward direction there for that whole time. Would we agree with that? Okay, so now if I wanted to find out how far I traveled during that time, an easy way for me to do it is to find the area under the graph to the x-axis. So I can find the area of that shape, and it would tell me how far I've traveled. So it's kind of a fun little shortcut. But here's the issue. Do I have an equation that can help me solve for the area of that shape? Do you guys know how to find the area of that shape with one equation? I don't. So I'm going to split it into shapes I do know. I know how to find the area of a triangle. I know how to find the area of a rectangle. and I know how to find the area of another triangle. Right? So I can find those individuals and then add them together. Triangle. Nope. Area of a triangle. 1/2 length times height, or base times height, or whatever you call it. Base times height over 2. There's lots of different ways you can come up with the equation for a triangle, but I think actually people say 1/2 base times height. I don't know. But it's the sides of the triangle multiplied together divided by 2. Okay, so I'm going to take the sides of my triangle. This side would be 2. This side would also be 2. So that means 2 times 2 over 2 gives me 2 centimeters, because this velocity is measured in centimeters per second. The middle rectangle here, this side is 2 and this side is 1. So what's the area of a rectangle? Length times width, right? So I'm going to take 2 times 1, and that gives me 2 centimeters. And then my last triangle over here, this has a side of 1 and a side of 2. So I take 2 times 1 divided by 2 gives me 1 centimeter. So I add all of those up, and that tells me I traveled a total during those 4 seconds of 5 centimeters. All right, so 5 centimeters traveled there. So if you were going to tell me what's the displacement of my object from 4 seconds to 5 seconds, how far did it travel from 4 seconds to 5 seconds? That means I've got to find the shape of that triangle right there. Okay, so to do that, I know this has a length, a length of 1. This is -2, right? So I'm going to take -2 times 1 divided by 2, and I get -1 centimeter. So why did my value come out negative? Why is my displacement negative here? I'm moving backwards, right? And how do I know I'm moving backwards?
Because it's past the...
Yeah, it's below the x-axis. Am I moving backwards during this portion of my motion? Nope. I'm moving backwards here and here. Okay, so let me get it right. I am moving forward right here. I'm slowing down, but I'm moving forward. Here, I'm moving backward. Okay, for this part of my motion and this part of my motion, because I am below the x-axis. My velocity is -1 and -2. Right? That tells me that I'm moving in the backward direction. I'm going to look at what's my displacement from 5 to 8 seconds on this graph right here. So I've got to find where 5 to 8 seconds is. 5 seconds looks like it's at D, and 8 seconds looks like it's at E. So that means I'm going to find the area of that shape. Is that a simple shape for me to find the area of? Yeah. Yes. Okay, so I'm going to take length times width. So this would be 3 seconds. This would be 40 meters. So I'm going to multiply those together. 40 times 3 gives me 120 meters. I know it's meters because my velocity is measured in meters per second. So I know my displacement is going to come out in meters. Does that answer seem rational? I want you to just take a look right here. For these 3 seconds, he's got his cruise control set at 40 meters per second. So 40 meters per second for 3 seconds should make sense to us that we're coming out at 120 meters. Okay? All right, and then we'll call it, okay? I want the acceleration from 0 to 2 seconds. So what does that mean I'll calculate? If I want the acceleration, I need to calculate the change in velocity over change in time, or I need to calculate from my graph the slope. Okay, so acceleration, right? We need to remember that this is coming from the slope of my line. So I need to calculate the slope of this line right here. I need you to pay attention. Here's the x-axis. It's kind of hard to see. There's the x-axis. but the labels for it are down below. So it goes 2, 4, 6, 8, 10. Oops. That's not an 8. 10, 12, 14, 16, 18, right? You see where the x-axis is, but our labels are way down at the bottom. So from 0 to 2 seconds means I'm trying to find this slope right here. To calculate my slope, I'm going to say that I went up 2 and actually over 2, right? And so that means my slope is 1 meter per second squared. We feel comfortable with calculating that? I knew the x-axis because of this one. Right? I only went one box, but that one box represented 2 seconds. Okay, do we feel okay about that? Okay. Find the displacement traveled from 8 to 10 seconds. So 8 to 10 seconds is here to here. So I'm going to go find my graph. That's here to here. So I need the area of that part of my graph, right? That's what I look for when I'm trying to find displacement. All right, so that means I'm going to find the area of that shape. This side of my triangle is 2. The other side of my triangle is also 2, right? Our scales are different on our x and our y-axis, so we're careful with that. So I'm going to take 2 times 2 divided by 2, and I get 2 meters traveled during that time. Okay? Questions with that part?
With the 2 on the bottom, where did that come from?
So that just comes from the equation for a triangle, right? Equation for a triangle is like length times width divided by 2, or 1/2 base times height. Okay, so it's just like taking 2 times 2 times 1/2. Okay, so whatever way is best for you. I usually will set it up like that, length times width divided by 2. Okay? Now the last question here actually doesn't require any math. What's my velocity from 16 to 18 seconds? So I just need to go find that portion of my graph, and it's right here. So if I want to know the velocity during this time, what do I need to do? All I have to do is go look at the y-axis. During this time, my cruise control is set, and it's set at -2 meters per second.